Okay. So here's what I want to focus on today then. God, there's just so much. I should have told you what's going on. Well, I had it off. If we're dealing with something like just polynomials, if I've got y equals a times x to the n and all this other garbage, we know what this graph is going to look like, dependent upon what a looks like and what n looks like. Okay? So if I have something like y equals 7x to the fifth, you guys should have an idea as to what that's going to look like. Okay? Why? Because we know that when n is odd, it's always going to do that. Okay? It's going to do that if a is positive. Come on. And it's going to do this if what? If a is negative.
I thought that was if a is odd.
Well, yeah, I'm going to get there. Okay? So, and that's true for 5, 3, 1, really, 7, okay? So this is true when I have odd exponents. You guys seen this before, right? Okay, so it's old hat. It's old hat. Okay, we're going to do a little activity with it here real quick. Okay? So now if I had something where n is even, it's not always going to be a parabola, but its end behavior is going to be like this if a is positive, and it's going to be like this if a is negative. Agreed? Okay. So now I just want to spend a little time. Let's do some analysis here. God, that previous deal. That was awful. Okay? So if I'm going to do something like x to the third, what's the waggiest it could get? Well, it could go something like this, right? Okay? So we're going to make a little chart. Degree. Zeros. And TP stands for what? No. In this case, turning points. Okay? So turning points are what you've before. What have you called these things before? Minimums and maximums. Okay? So if I have a degree of 3, how many zeros can I have? 3. Would I have to have 3 zeros?
No. Yes.
Well, let's take a look at it. Let's just make a couple sketches on like a different sheet here so we don't have to. What I could do is could I just have 2? Could I just have 2 zeros?
Yes. Yeah.
How?
No.
I can, but how?
A parabola.
Well, a parabola wouldn't be degree 3. I'm dealing with the third. Degree 3. How could I have where I just had 2? It's possible. Okay, I can have 2. I can have 2. Well, I'm thinking about with an extra third. I could have 2. Could I have 1?
Yeah. Yes.
Yeah, if I just slid this one down, I could have 1, right? How many turning points could I have?
Infinity then?
2. I could have 2. I'm not sure how I draw it to get 3. Because remember, we're having a high point and a low point.
Well,
Okay? Would I have to have 2?
No, you don't have to. Right? Yes, you do. Yes.
Not necessarily. And this is. I'm glad we're having these conversations. That's an x to the third.
Oh, yeah.
I could have 0. Could I have 1? Could I have just 1? 1 maximum? Would I have to have a second? Well, if it's x to the third, how's it got to finish? It's got to go back up. So I'm going to have 2 or 0. Okay? What if I have x to the fourth? Okay. So my degree is 4. How many zeros could I have?
4.
4. Okay. Do I have to have 4?
No. Yeah, 3.
How could I have 3, Gigi? You're right. I could have 3.
You can just move it down to where it's at the top of that middle hill.
Oh, okay. So like this?
Yeah.
Yeah, there'd be 1, 2, 3. I could have 3. Could I just have 2?
Yeah.
How would I have 2?
Just do 2 arrows.
Bring it all the way down.
Oh, bring it all the way down. So you're saying I could do this?
Yup.
Like that? Yeah, that'd be fine. Could I have 1?
No.
No. I can have 1. How would I
Yeah,
have
you
1?
can. You just move it all the way up to like the bottom of the lowest valley.
So like this?
Yeah.
Yeah, I could have 1.
Come on, guys.
Good job, Gigi.
Fizzing his head up.
Could I have 0?
Yeah.
I could move it all the way up.
Just don't touch it at
Okay.
all.
How many turning points could I have?
3.
3.
Or 0.
I could have 0. Ooh, could I have 0? Ooh, maybe I can't have 0. Would I have to have at least 1 turning point? Yeah, because it's got to turn somewhere and go back up. Okay? So here's what I want you to observe more than anything. We could go down the wormhole on this, but if it's degree 3, we could have 3 zeros. If it's degree 4, we could have 4 zeros. If it's got degree n, we could have n zeros. We wouldn't have to. We could have any number less than n. Now, if I've got degree 3, maximum number of turning points I could have is 2. 4, maximum number of turning points I could have 3. And the maximum number of turning points I could have is n minus 1. Okay. So now let's take a look at these. Where's my notes?
I do remember this.
Good.
Yeah.
Oh, I think it's kind of a cool thing once we get going. Okay. So let's just how about we just do some algebra?
Nice. I love algebra.
Y equals x to the third minus 5x squared plus 6x. Our goal, find the zeros or the x-intercepts. They're the same thing. Or the roots, same thing. So what can I do? Take out an x. Take out whatever you can.
X squared minus 5x plus 6.
Okay, good.
Negative 3, negative 2, 0. X equals 0, 3 and 2.
X equals 0.
3 and 2.
There we go. Those are the only values of x. Those are the only values of x that would yield a 0 for my height. Okay? Now let's raise up the difficulty just a little bit. Y equals x to the fourth minus 3x squared minus 4.
Oh, can't take an X out.
I can't take an x out.
So you would out of the 4.
Nope.
Alright, so what you gotta do? You gotta do. It's something with you gotta. The x to the fourth minus 3x to the second. And you're gonna take out. Put those two.
No, just relax. Okay.
Oh.
Okay, now, hey, see this over here? This is a quadratic form. This is a quadratic. A number, something, and that something squared. This is of quadratic form. We have a number, we got something, x squared, and what's x squared squared?
4.
X to the fourth. So this, we can factor it. We're just going to put x squareds in the front.
So
X minus 4 plus 1.
Oh, okay, yeah.
X is 2 and X is negative.
Can we factor this any further?
Yeah.
Yeah. X is plus or minus 2 or X is plus or minus 1. I think. Isn't it?
I can't factor that.
So no solution.
From this part, there's no solution.
Yeah.
But there's still solutions with the X minus 2s.
So my answer is my x-intercepts are
2 and negative 2.
2 and negative 2.
What?
The sum of two squares you can't factor. And if you think about it, why? Yeah, it would give me imaginary because I'm squaring something and adding 1. X is not going to be real. Okay. Last one. See how well you remember this.
Okay. Oh, it's X. That's cube. Perfect cube.
It's cubes.
X plus 2.
Wait, I want to try to solve.
We already did it wrong.
It's not to the third. If I would take x plus 2 to the third, it would have a bunch of x squareds and x's and stuff in the middle. Yeah.
So that it would be
X plus 4x.
plus 2. Oh.
Okay. Now, there's a formula that you guys knew at one point in time that goes like this.
Oh, yeah, this was like first grade.
Remember that?
I don't remember that.
You don't remember this kid?
Okay.
Rewind.
Put it back in.
Now let me show you what happens. If I do multiply this out just to convince you, look at what I get. I get x to the third, even though we're done for now. We're going to come back to it. My x-intercept is negative 2. That's it. Okay? But if I would multiply this out, what happens?
Most of it cancels.
Why does it cancel? Because we've got a negative and a positive here, and it's set up just the right way. So my final answer on this one is just x equals negative 2.
Okay.
There will never be any solutions from this. It's always going to give you imaginaries. So honestly, folks, I would have this written down somewhere.
I wrote it down in my notebook.
Good for you.
Oh,
That pink minus and plus, that is actually the formula for the difference of two cubes. Okay? And I've got a shortcut here. Once you're done writing it, I've got a little mnemonic that'll help you. Okay, got it written down? Okay, here's the deal. I think A and B are pretty easy to find. Don't you think? Like here, x to the third, the cube root of that was x. 8, the cube root of that was 2, right? So now all you got to do is this. Square it to get this. Square it to get this. Multiply the 2 to get your middle term. And get your sign right. And then square that. So it's square it, multiply the 2, square it. So come back here. Square it. Multiply the 2 with the opposite sign. And square it. There's your little pattern. Okay. I wish this class was like longer.
Why? Because you love us?
No, because to teach this properly, I really think we just need more time.
What class do you have fifth period?
Fifth period, algebra 2.
Yeah, but for a whole hour on Friday.
I can't. I got weights
We can't change the. Okay, so let's do a little check on something here, folks. With your hands, show me. If I add f of x is equal to blah 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 blah, but I have a negative 2x to the fourth, show me your hands what the end behavior would be.
Oh, what the end behavior would be?
Yeah, end behavior. So it's going to go like this, right? So the way we're going to say that is this. The limit as x approaches infinity of f of x is negative infinity. Have you used that notation before? Okay, well, we are using limit this time to get you ready for next time. Because this is the way the back of the book is going to do it. So what this is saying is the limit, which means what's happening to my function, where am I taking it, and what's happening to my function. So the limit of this function as x gets really big is negative infinity. We could all say the limit as x approaches negative infinity of f of x on the other side is also negative infinity. So what this is saying on the right side, it's going down. On the left side, it's going down. Get used to that notation. We will need that notation throughout. Matter of fact, look on the board over there. We're doing limits in calculus right now. So you need to be able to do that. Okay?
That look easy.
Okay. I just need to get out of this funk, man. Okay. 93. Numbers 46. So on 46, get one radical by itself. Carefully take the FOIL it out, times itself on the other side, and then you'll be okay. $54. So yes, you may see something like that on a quiz. So take it seriously. Then we're going to do page 104. (13) through 17 odd. That's where you're just describing its end behavior using limits, like we just went over. 23 through 31 odd. And I'm going to give you a challenge problem.
What?
43. Actually, I'm going to remove the challenge problem label. Do a scatter plot, figure out what it looks like, and if it's a quadratic, ask you to do a quadratic regression. If it looks like a cubic, do a cubic regression. Okay? Look at the scatter plot and then go from there.